this is a walkthrough for the November 2018 Maths Higher Tier Unit 2 Calculator paper. Get straight into it. Okay, first one is a percentages question. A number is decreased by 12% of its value. It's done 3 times. Okay, circular multiplier you would use. So multipliers, remember, is you always start from 100%. If you're increasing, you add. If you're decreasing, you take away. We're taking away 12%. That leaves us with 88%. As a decimal, that's 0.88, and we're doing it 3 times, so to the power of 3. Okay. Part B, calculate the percentage change. So the formula you're going to need for this is change divided by original times 100. Change divided by original times 100. So to find the change, you would take away. So 45.9 take away 42.5. The original is what it was on before. So that was 42.5 because it increased. Times 100. Don't forget the times 100 to actually turn it into a percentage. And you should get 8% for that. Okay. Question 2 is a Venn diagram question. Okay, you've got to be a little bit careful here. That funny little sort of E symbol starts with a universal set. It means all the numbers. So our universal set is every number between 74 and 80, including those. So your Venn diagram should go into a rectangle with your little E that just tells you that all of the numbers are in the rectangle somewhere. They're not necessarily in the circles, but they're in the rectangle. We need 2 different sets. So we need even, and we need multiples of 3. Okay? Multiples of 3. Okay, now they've called them A and B. So set A, set B. And then all you've got to do is work your way from 74 to 80, putting the numbers in the right boxes. So 74 is even, but not a multiple of 3. 75 is odd, and it is a multiple of 3. 76 is even, it's not a multiple of 3. 77 is neither, so 77 goes outside. 78 is even, and it's a multiple of 3, so 78 goes in the middle. 79 is neither, so somewhere on the outside. And 80 is even, but it's not a multiple of 3. Okay, but make sure it's in a rectangle, otherwise you will lose a mark. Okay, can't really have 77, 79 floating anywhere on the page. They've got to be contained in this box, which represents all the numbers 74 to 80. Okay, question 2 done. Question 3 then, pretty standard stuff this on a maths paper. Fill in the missing values in the table, plot the graph. Okay, the equation is x squared plus 4x minus 1. So if we start with minus 2, we've got to do minus 2 squared. A minus times minus is a plus, so that's 4. We've got to add 4 times minus 2. So we're adding minus 8, which when we actually come to do it, we'll take away. And then we've got to take away another 1. So it's 4 take away 8, which is minus 4, take away another 1, which is minus 5. And then start again. This time, though, the number we're working out is positive 2. So it's 2 squared, which is 4 again. Add 4 times 2, which is 8. So we're on 12 so far. Take away 1 is 11. Now, if you're struggling to figure out the values, best thing to do, I would suggest, is plot all of the numbers that you've been given and put the 2 missing ones where it makes a nice curve. So here is my curve using those numbers. Okay, no funny bumps or wiggles. If you're struggling, like I say, just put the crosses somewhere where it looks good. The second part of this question then asks us to draw the line y equals 2 and write down the point where it intersects or cuts the curve. So if we put a line across through 2, so this is y equals 2, and then all you've got to do from the points of intersection is read down and take the values off. So it looks like we've got minus 4.6 and about 0.5 or 0.6 there, okay? So go back a page. So minus 4.6, that minus 4.6 and 0.6. one's done. This is just testing your sort of knowledge of numbers. Okay, factors, multiples and things like that, squares, square roots. We've got a number between 55 and 83. The square root of the number is greater than 8 but less than 9. Well, 8 squared is 64 and 9 squared is 81. So that cuts it down a little bit because we're looking for a number that's bigger than 64 but less than 81. The highest common factor of 49 and our number is 7. So that tells me that the number is in the 7 times table if 7 is a factor of it. So if I look at the numbers between 64 and 81 and just take the ones which are in the 7 times table, it's only 70 and 77. So we've used that clue, we've used that clue, we've used that clue. The last clue to help us pick between these says that 3/5 of the number is a multiple of 6. Well, to find 3/5 of something, you divide by 5 and then times it by 3. So 70 divided by 5 is 14. Times that by 3 is 42. 42 is a multiple of 6. So 70 must be our answer. I mean, 3/5 of 77 is not even an integer, so it couldn't be 77. So that's quite a quick one, as long as you're happy to work with factors, multiples, square numbers. So 70 is our number. Okay, number 5, trial improvement. If you're going to be doing a paper 2 maths exam and you don't know how to do trial improvement, you definitely need to do some revision on it. So if we make a table to hold our values, that last column is where we say whether it's too big or too small. Okay, too big or too small. This is our calculations, and we're aiming for 107. So that's what we're going to base our too big, too small on. In our first column there, we pick our value for x. Okay. I always start with the numbers we're given, so 5 and 6, just to check I'm doing it right in the calculator. So 5, so this is 5 cubed minus 13 times 5 is 60, which is too small, which is exactly what you'd expect if it's between 5 and 6. And 6 should come out too big. 6 cubed minus 13 times 6, that's 138, which is too big. So I know now I'm typing it in properly because I've got one too small, one too big. And now you start looking properly. Start with the midpoint, so 5.5. Type all that in, you should get 94.875. 94.875, which is too small. So we need to get bigger. 5.6 then. Take baby steps, don't jump any. 5.6 comes out as 102.816. Which is also too small, not by much, but it is too small. Because of the cube, the numbers are going to get bigger quickly. You don't need to make a massive change to x to get a big change out for your answer. 5.7, that comes out as 111.093, which is too big. Okay, so we know our answer is between 5.6 and 5.7. We've just got to pick which one of those is correct. We are only working to one decimal place, so it's either 5.6 or 5.7. To decide that, you need to go halfway between them. So 5.6 was too small, 5.7 was too big. You need to work out and show that you've worked out. So write this down. You need to try 5.65. Okay. If you put the numbers into the calculator, 5.65 cubed, take away 13 times 5.65 is 106.912. It goes on a bit, that one. Okay, 106.912. Remember, we're aiming for 107, so that is too small. Which means if we were going to continue to look, we would go bigger than 5.65. We would go to the right on the number line. So our answer to one decimal place is 5.7, and I'll just put in brackets underneath to one decimal place. Okay, you've got to do this calculation at the bottom for 5.65 to get all of the marks. Okay, number 6. This is all about sort of graph work, gradient and intercept now. Okay. For For gradient intercept, it's got to be in the format y equals mx plus c, where m is the gradient and c is the intercept. We've got 6y equals 3x plus 7. I need to get rid of the 6 from the left-hand side. So divide everything by 6. So that's 3 divided by 6. X plus 7 divided by 6. 7 divided by 6 is not very nice, but 3 divided by 6 is a half. So the gradient is a half for part A. You've got to get it into the correct format, y equals mx plus c. Okay. Where does the line 5x plus y plus 3 equals 0 cross the y-axis? Well, if we get it into the form y equals mx plus c, we're looking for the plus c part. So 5x plus y plus 3 equals 0. We want y on its own on the left-hand side. So the 5x has gone over and become minus 5x. The plus 3 has gone over and become minus 3. So the gradient is minus 5. The intercept, which is what we are looking for, is minus 3. And for part C, looking for where these two lines intercept. Okay, what we need to do is just find which coordinate works for both equations. So remember, in a coordinate, the first number is your x value, the second number is your y value. It takes a little bit of mucking around, but the coordinate that works for both is 5, 2, okay, because 5 add 2 is 7, so that's that one satisfied. And 5 take away 2 is 3, so that's that one satisfied. I mean, I've seen worse ones of those, and for 1 mark, it's not worth spending more than a couple of minutes on it. But all you've got to do is work out which coordinate works for both equations. I'll pause this video here, and we'll carry on with question 7 in the next video.